Hi, good day. So for today, we are going to talk about the introduction to ANOVA. First of all, ANOVA means Analysis of Variance. ANOVA is a type of statistical analysis that can be used if we have three or more groups of data that are normally distributed. Now, there are four commonly used types of ANOVA, and these are number one, the repeated measures ANOVA. The repeated measures ANOVA can actually be used if we have three or more groups of data that came from dependent samples. We also have here the one-way ANOVA. A one-way ANOVA can actually be used if we have three or more groups of data that came from independent samples. We also have here the factorial ANOVA, which can be used if we have two or more independent variables. And we also have here the MANOVA, which can be used if we have two or more dependent variables. Now take note that in our next lessons, we are just going to focus on the repeated measures ANOVA and one-way ANOVA. Now the repeated measures ANOVA has actually a non-parametric counterpart, and that is the Friedman test. And the one-way ANOVA has also its non-parametric counterpart, and that is the Kruskal-Wallis H test. Now what is the idea behind ANOVA? Now in any research, the goal is always to know if our independent variable can cause variation in dependent variable, or if our independent variable can affect our dependent variable. Now take note that this variation here may happen due to number one, our independent variable, or number two, random chances or differences. Now in ANOVA, the variation due to independent variable is known as between the groups variation, this one, okay, and the variation due to random differences or error, this one, is called within the groups variation. Now for you to be able to understand further these two variations here, let's have an example research where we can actually use the ANOVA. Now here is an example of research where we can actually use the ANOVA. For this one, we have different methods of learning mathematics. Now for this research, we actually obtained four different groups of students, and each group has four members. The first group only experienced method number one. The second group only experienced method number two. The third group only experienced method number three, and the fourth group only experienced method number four. And after exposing them to different methods of learning mathematics, we let them took 50-item test in mathematics, and we obtained their scores. Now these are the scores of the students who underwent method number one. These are the scores of the students who underwent method number two. These are the scores of the students who underwent method number three. And these are the scores of the students who underwent method number four. Now our independent variable here is the learning method, while our dependent variable is the score in 50-item math test. Now as we have noticed here, the scores of the students who underwent method number 1 differ from the scores of the students who underwent method number 2, number 3, and number 4. So obviously, there are variations in our scores here. Now one might say the reason for those variations in score might be the learning methods or our independent variable, okay? In this case, those are the learning methods, okay, that are actually applied between the groups. Hence the name between the groups variation. However, if learning methods or our independent variable is the sole reason why we have variations in scores here, then how come that students A, B, C, and D got different scores even if they are exposed to same method of learning mathematics? So obviously, there are certain factors or there are random factors, differences, or errors that may cause these variations within the group. Hence the name within the group's variation. So again, in research, our goal is to know if our independent variable, in this case learning methods, can affect the dependent variable, in this case the scores in 50-item math test. Now in ANOVA, we want to know the extent of variation due to independent variable or between the groups variation, and not due to random error or within the group's variation. And how do we do that? We can actually do that by dividing the value of variation between the groups to the value of variation within the groups. And we will have here the F value. The F value is actually the value in ANOVA. Now here, if the variation between the groups, that is actually the variation that is caused by independent variable, is greater than the variation within the groups, again, that is the variation that is caused by random error, okay, it will actually produce higher F. And higher F means higher chance that the variations in scores are actually produced due to our independent variable and not due to random error. That is actually the primary concept of ANOVA. Thank you for listening and good day.